Okay, our next example for finding the domain is f of x is equal to, it is another rational expression, it is in the form of a fraction, x to the fourth divided by x squared plus x minus 6. So again, we want to find all values of x, that's the domain, that when we actually place the values in for x within our function, it will be able to produce us a valid answer, okay? So again, when we consider a rational function, you have to start analyzing the fraction. In the numerator, this is a power, x to the fourth. Well, any value of x is valid. You can plug in any value of x and you will get a solution, okay? There's no restrictions on the power function x to the fourth. We can place in an x value and get out a legitimate answer, okay? But there are some examples, and I'll go ahead and hint to it now, those of which may be like the square root you'll find in the numerator. That's where we're going to have to pay a little bit more close of attention. Or even if it had the absolute value function in the numerator, we have to be a little bit more careful in that situation. All right, so the numerator again is okay. There's no concern about what possible x value that will make this function worthless or make it or will not make sense. So again, we're concerned with what are those x values in the numerator that actually will produce a value of 0. All of those x values that will produce a 0 will not be in the domain. So when we consider rational functions, the first thing we ask ourselves is, we say, where is x squared plus x minus 6? Where is that thing equal to 0? Once we find out those solutions, then my domain will be everything except those two solutions because it's a quadratic equation. Okay, so this is a trinomial, and these are the easier type of trinomials to factor because there is no leading coefficient other than 1. So we simply ask ourselves, what two numbers can multiply together to get me 6, and those same two numbers will subtract to get me a positive 1 that's sitting in front of our coefficient of our middle term. So those two numbers are 3 and 2. So we break this up to x and x. The two numbers that I use, again, the two numbers that multiply together to get 6 are 3 and 2. These same two numbers will subtract because this is a minus sign. The same two numbers that subtract to get me a positive 1 will be positive 3 and negative 2. Positive 3, negative 2 combines to be a positive 1. So again, now we take these two factors and we set them equal to 0. X plus 3 is equal to 0. And x minus 2 is equal to 0, and clearly these are easy. One step, this is x is equal to negative 3, and x is equal to 2. So what this says is, the only values that will produce 0 in my denominator are the values 2 and the values negative 3. And I suggest that you take these values, substitute them in, and convince yourself that you will get 0 if you plug those in. So every other value other than this actually works. So if we write this as in an interval notation, well, we say, well, my domain will come from negative infinity all the way to negative 3 union. Now we also get to include values between negative 3 and 2. And finally, so forgive me for the writing here, another union which would be strung out this way, from 2 to positive infinity. Okay, but we want to actually write this in set builder notation. So I'm going to erase up top. So as far as set builder notation, we say that again, which is the better way, more professional way to write, the domain is the set of all x such that x does not equal negative 3 or x does not equal 2. So that's my domain set right there.